In this fifth video in the tandem queuing module, we're going to look at something called balking. And if you remember back to the end of the third video when we implemented the capacitated buffers, one of the things you might have noticed is that entities, if the server 1 is full, entities back up into the output buffer of the source. So let me stop this, go back and change this to capacity 0. And when we run now, the entity, when the server's busy, the entities back up to the output buffer of source 1. So the net effect here is that we still have buffering for server 1, right? Because while they can't reside in the input buffer technically, the entities are in the output buffer here, and so whenever the server 1 is available, the entities are just grabbed from the output buffer of source 1. So that doesn't really implement what we're after of having this starvation and blocking when server 1 is busy. So what we need to do if we want to implement that is we have to decide how to proceed with source 1. Now, unlike the server objects, which have explicit buffer capacity properties, the source doesn't. So there's no buffer capacity. There's nothing in the source that says, let me limit this capacity. And the reason is because that Simio would have no way to know what you want it to do with the entities. So when the capacity of this buffer were reached, what happens to the entities? With the server object, then you can simply say we're not going to allow entities to enter the object, and so the previous objects handle what to do with those entities. In this case, we can't do that, so we have to explicitly add some logic. And so what we need to do is what we want to do is, if there's no room to place the entity, let's just destroy the entity. In other words, what I'm going to do is I'm going to create a sink right here, and then I'm going to send entities to the sink. So if the buffer and the processing contents are full in server 1 when an entity arrives, I'm simply going to send it to the sink. And so I want to track that, so I'm also going to create a status label here and just keep track of the number of entities that enter this input buffer. So my expression that I want here is sink2 input buffer number entered. And so that's just going to keep track of how many entities enter. So if I were to run right now, what we expect to happen is, since we haven't set the link weights or anything, we would expect about half the entities to take each one of the path. Because by default, entities that depart use the selection weight, and our selection weights are both set to 1. So selection weight 1 here, selection weight 1 here, and so by default they're just going to half go down to the sink. Now clearly that's not what we want. What we're after is a conditional branching. We're after a conditional routing of the entities. And so let's look at how we want to do that. We are going to say, in order for the entity to be allowed in the system, we need to add together the input buffer capacity and the server capacity, and that has to be greater than the contents of the input buffer plus the contents of the server. So for example, if the input buffer capacity is 0 and the server capacity is 1, we want to make sure that the server is idle if we're going to allow the entity into the system. And this expression will work with any input buffer and server capacity. So what we need to do now is we need to translate this logical expression into a Simio expression. And so there are 4 components here that we need to handle. There are 2 capacities, input buffer and server, and then the input buffer contents and server contents. And so the input buffer capacity is simply server1.inputBuffer.capacity. The server capacity is server1.capacity. Input buffer contents, server1.inputBuffer.contents, and server contents is server1.capacity.allocated. So this is the allocated capacity on the server. So now that we have the expression, go back to Simio, and there are a couple of ways that we can implement this. And if you haven't watched the module on entity routing, you should do that. It covers comprehensively the methodology and the logic associated with routing entities. So what we're going to do, the two ways that we're going to look at, one way is by using an add-on process associated with the source, and the second way is using selection weights. And both of these methods will involve using the expression that we just built. So let's do the add-on process first. So what I'm going to do is I'm going to select my source, go to my add-on process, and after I created the entity, right before it gets routed, I need to make a decision. And my decision is, which way am I going to send the entity? And so our decision is a conditional, and the condition is exactly the expression that we just built. So I need to make sure that the server 1 input buffer capacity plus server 1 capacity is greater than, forgot my parenthesis here, greater than server 1 input buffer contents plus server 1 capacity allocated. So this is just simply the expression that we just built in the, I must have typed something wrong here. Let me grab this guy and say, what did I do wrong here? Server 1 input buffer contents plus server 1 capacity allocated, unbalanced parenthesis. Put my parenthesis at the end, and there we go. And so now we have our decision. Let me just expand this and make sure that we have this totally right here, which we'll check it when we run anyway. And so I have two branches. If the true branch, that tells me that I have remaining capacity. So I'm going to use the set node, and I'm going to specify that in this case I want to go to the input at server 1. Otherwise, I'm going to set node, and my destination will be input at sync 2. So if we have capacity, go to server 1. If we don't have capacity, go to sync 1. And so now when we run our model and set the capacity to 0, instead of seeing entities queue up in the output buffer, we should see the number enter here if the server's busy. And so that's in fact what we see. And if you go look at the experimentation, you'll note that the throughput now drops even further because we are essentially removing the capacity of the buffer in server 1 by implementing this balking logic. So the second method that we'll use uses that same basic expression, but instead of using an add-on process, we're going to use the selection weights. So what I'm going to do is I'm going to go to my add-on process, so I don't have to type this all again. I'm just going to select my expression. So this is the same expression that we had before that we want for the true branch. So I'm going to copy that to the clipboard. Then I'm going to go back to my model, and I'm going to assign this exact expression as my selection weight for the true branch. Okay, so now we make this a little wider here so we can see that. So I'm saying the selection weight is a Boolean expression. So this expression is either going to evaluate to true or to false. And I'm going to have the alternative for the selection weight for the sync. And so now I'm going to just say, instead of it's greater than, this is either less than or equal to. So if we're at capacity or greater than capacity, we want to send the entity to the sync. And so now I can go back and I can say, I don't need this add-on process anymore. So let's actually go ahead and get rid of the add-on process. So just delete it here. And now when the entity depart from the transfer node, by default we're going to use the selection weight property. And so what happens is, if there's capacity remaining, in other words, if this expression evaluates to true, then this selection weight will be set to 1, and this selection weight will be set to 0 because they're alternative. Similarly, if there's not capacity remaining, then this selection weight will be set to 1 and this one to 0. And so as we run our model, we should see that we achieve the exact same thing as we had before when we had the add-on process. So the key here is understanding the expression that we built. So go back to our our PowerPoint, understanding what we wanted, that we needed to evaluate the total capacity against the total number in system. And then we converted that to semio expression. And once we had the semio expression, we had these two methods to do this. One was using the add-on process in combination with set node, and the other was by using selection weight. Again, I would encourage you to watch the complete module on entity routing to see all of the details.